not sacrificing. No, hey, but those are good food and good too. I need a plate. Sorry, I can't eat.
You look like you're good at basketball.
No, you're fine. You know, it's funny you mentioned that.
I am good at I can beat you. I don't know about all that.
Yeah, I can
I
teach you
can
ready.
barely.
All right.
I prefer not to get beat.
Good morning, everyone. Welcome back to Physical Geology 1403.
Good morning.
We got almost everyone. We'll get started. How was the weekend? Anything fun or interesting?
I'm trying to think. What this weekend flew by like that. I don't think much happened.
No?
I washed my car.
You washed your car.
I cleaned it.
Mine desperately needs a wash.
So did mine.
But it's a Jeep, so it looks good dirty too.
That's true. All Jeeps look good dirty.
Yeah. The price of gold is the highest it's ever been right now.
Really?
If anyone's interested. $2,954 per ounce.
Per ounce?
Per ounce.
Why is it so expensive?
Because of the cost of extraction plus the demand for it.
Why is there such?
We measure it in the ounce. And so when I say an ounce of gold, you think probably a coin, right? One of those ounces of gold. I wish I had one I could show you, but I don't have $3,000 lying around. I could do for that. But that's not the primary use of gold. You know what the primary use for gold is?
Jewelry?
I mean, jewelry it's up there, but not
Technology?
Oh, yeah,
technology. Good job. Okay. Gold is an incredible conductor. And so all the best technology, top tier, military, government, anything that you really want to be able to rely on has gold as the conductive units in there, the conductive material, not copper, which is what most of the rest of us use. Although fiberglass is quickly becoming a common conductor as well.
You said a what?
A what?
A fiberglass?
Yeah.
What's that?
It's extremely clear, highly conductive, essentially synthetic quartz. You know like AT&T fiber? Like that internet option that you can have where they bury the line under your house, right? That's them using this high grade, super clear conductive glass, basically. So yeah, gold, super high, highest it's ever been right now. It'll keep going. What else? What else is interesting?
I got to talk to my cousin for the first time in like 5 years.
Got to talk to your cousin for the first time in 5 years. Wow. That would make sense. Thank him for his service for me next time you talk to him. Hopefully not in 5 years. Hopefully sooner than that. Has he been deployed?
Yeah, he's in Greece right now.
Oh, poor guy. He's in Greece. Yeah. Right. Okay. That's cool. Greece is one of 3 places in Europe that I would like to go back and see that I haven't seen yet. I'd love to see Spain, Italy, and Greece. I could get them all on one trip. Yeah, just hop across the Mediterranean. Yeah. But yeah, that's probably a ways away. I'd love to make that happen sometime, though. I've been to Germany, Austria, Switzerland, France, Scotland, Ireland, England, and Iceland. I'd love to hit those 3 sometime, though. That's awesome. That's awesome. That's awesome. That's very thoughtful. Look at you having all these geology connections before you even came in my classroom. Yeah. The Argentinian president scammed his citizens. How?
A crypto rug pull.
Ah! What was that thing? The Haktua girl did that.
What? Oh yeah, that's right, huh? That's right.
She did the crypto pull, the crypto rug pull. Yeah. I guess the Argentinian president decided to do that.
You know what?
That's
a
so
great
dumb,
idea.
though. Why would you do that when you're a high-profile person? Oh, Trump scams people all the time.
All the time.
Buy a Trump watch, buy a Trump book, buy Trump
I don't
shares.
get how people forgot when Obama changed, like, no more Aunt Jemimas. He was changing football team names. He was erasing history, taking down
Yep.
statues. Nobody talks about that.
No, it's
But
because
Trump wants to call it the Gulf of America, and everybody's got their panties in a wad.
yeah.
I don't get that.
Yeah, no, that's a fair point. It's the newest and baddest thing. Everyone, I remember how much of an uproar everyone had when Obama was in
I
there.
mean, he was literally erasing history.
Yeah.
Like murals that have been there for hundreds of years, and
Yep.
statues and
Yep.
school names. Bands were changing. It's like no longer Lady Antebellum. I mean,
Yep.
it's no longer Dixie Chicks. Come on,
Yep.
people.
Erase history, and we are doomed to repeat it. And that no. I absolutely agree. And when Biden was in office, everyone had an issue with Biden, right? And now Trump is in office, and everyone has an issue with Trump. It's just the way that it goes, fortunately. Yeah. Nothing really more to say about it than that. People tend to have short memories.
I mean, everybody was all for it when Obama was doing it.
Oh, not everybody. Not everybody. Anyways, we should probably keep this from devolving to too much of a political conversation. Too much. A little bit's fine, but this does go on YouTube. Okay. What else? Nothing? Okay. By the way, I haven't talked to my cousins in like 6 or 7 years, but that's mostly because we were never tight.
No, we were very close. We just don't have time to talk anymore.
Yeah. I always, because, I grew up in the Navy, so we were moving around all the time. I maybe saw my cousins 2 or 3 times in my entire childhood. So I've just never been close to them. And so, like, I keep up with them. Like, my uncles will text the family group and say, hey, this cousin is now driving. And I'll be like, oh, yeah, that's cool. Oh, wow, she's that old. Yeah. But I've never really been close because we've never had that much time together.
Me and my cousins, we all used to talk. We used to see each other twice a week. Now we try and hang out once a week.
That's fantastic. I love that you're close enough to family to do that. My closest family is my sister-in-law, who is 10 and a half hours away in Phoenix. And then my closest blood relative is about, how far is it to Utah? Like 30 hours? 20-something hours? Far, yeah. Probably not 30. Probably more like 20 hours, but yeah. We don't get to see them much. Anyways, all right.
17 hours.
17 hours, all right. You know the drill. Exam 2 review day. Today is dictated entirely by you. Your questions, the quality of your notes, how prepared you feel. If you don't feel prepared, this is the time to try and fix that.
Which lectures does exam 2 cover?
Yes, just module 2. So lectures 8, 9, 10, and 11. It is half the amount of content as exam 1, and so will be half as long.
You said 20 questions.
20 questions. 20 questions on this one. 100 possible total points. Covering module 2. All the usual suspects. As far as the types of questions you'll see there. Short answer, multiple choice, true, false. What the distribution of those different types of questions will be, I won't say. Could be 19 short answer questions and 1 true false.
Or you can be so nice and just give us multiple choice.
I do give you multiple choice, just not all of them. If I gave you all multiple choice, I guarantee there would be someone in every class who would just go C, 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 C.
Absolutely.
That might be you.
I do
A, B, C, D. I met someone one time whose legal name was A, B, C, D, and they introduced themselves as Absidy.
You're joking. You're
I am not joking.
Well, like legal name is just A, B, C, like just
Yes.
the letters.
Just the letters A, B, C, D, Absidy.
Oh,
I want to see that birth certificate.
I also, in Louisiana, I didn't meet this person, but my wife was a rental agent for the apartment complex that we lived in. And she showed an apartment one time to a woman whose name was A, B, C, D, E, F, G, H, I, J, K, M, N, O, P.
You're joking.
And her name was Noelle.
Oh my god.
She changed her name to that
what?
herself, Noelle. Because from the list of letters, L was missing. She thought it would be funny. That's
No.
Louisiana, I guess. Yeah. Noel.
It's like naming your kid a number.
Yeah.
Or a letter.
Yeah. And then another time I was reading an article about someone who named their kid Optimus Prime.
They watch Family Guy.
Yeah,
for
so
sure.
this is the world we live in.
Yeah, some parents. I can't think of a name. Let's just name them the alphabet. That's a great idea.
Yeah. Yes.
Okay, you, on the last exam, you put something on there on the water cycle. Are
Yeah.
you still going to include that on? exam?
I will not expressly ask questions that are exclusive to Module 1 content, but because all of the modules build on each other, the things you learned in Module 2 make sense because of the things you learned in Module 1. And so I will ask you questions expressly about things in Module 2, but you may want to explain them using information from Module 1, if that makes sense. I'm not saying that you won't have any Module 1 stuff on this exam. I'm just saying that the questions themselves will be referencing things we learned in Module 2.
Because the water cycle is lecture 8, so that may also be included again.
Yeah, well, the water cycle, the hydrologic cycle was mentioned in the first exam because it is very relevant to things like the sedimentary process, right? So that's why that took part in exam 1. But I absolutely could reference it again because we discussed groundwater and running water and glaciers in Module 2.
Yeah.
Water cycle as pertains to sedimentary cycle.
Right, that's the relevance there to Module 1.
Okay.
What else?
So can we go over that sedimentary cycle again?
We can go over wherever you want.
Okay. Yes.
Okay, sedimentary cycle. It begins with sand. I'm kidding. Let's not start there. Let's start with a rock. We've got a rock. Let's say we've got some granite, okay? A chunk of granite. And as time goes on, what happens to it?
I almost said dissolves. It erodes.
It breaks down. And what do we call that?
Weather.
Weathering. And which two kinds of weathering are there?
Chemical.
Mechanical weathering and chemical weathering, which is what you were just talking about, dissolving, right? That's an aspect of chemical weathering, okay? So it is breaking down mechanically, aka physically, big piece to smaller pieces, and chemically. Some of it is dissolving in contact with chemicals, okay? So as it starts to break down through this weathering process, one way or the other, the pieces are reduced to smaller pieces, and the smaller pieces eventually get rounder. And as they get rounder over time, they become these things that, or different kinds of sediment, okay? So your quartz, for example, often will become sand. Things like your amphiboles and your feldspars, those will break down and become clays and iron oxides. Biotites will become clays, so on and so forth. So eventually, let's say that this is a very, a much older sediment, okay? Let's say that a lot of weathering has happened to this sediment. So pretty much all my softer stuff has been broken down into smaller particles that have been carried away, leaving behind the harder minerals that were in that granite. Quartz, right? Very common in granite. So we've got a lot of quartz sand left over from an extended period of weathering. That sand gets buried under more sediment as time goes on. More sediment is piled on top of it. It gets shoved deeper and gets heated up as time goes on underground. This introduces something called lithification, the process of compaction and cementation that takes sediment and makes a sedimentary rock. You go from loose sediment to a compacted rock through lithification. So loose quartz sand can become sandstone because it's been crushed together, and cement, dissolved minerals, have formed between each of those grains, holding them together. Now that rock can get shoved even deeper and eventually get metamorphosed, or it can be re-exposed at the surface and undergo weathering again and become sediment again. And that sediment can become part of a new sedimentary rock again, so on and so forth. This is the sedimentary process.
Is this the same to explain like just the rock cycle? Or is that different?
It's one aspect of the rock cycle. The rock cycle covers igneous process, sedimentary process, and metamorphic process, and all the stages in between that go from one to the other. How igneous rocks crystallize, right, from magma, but then they have to be weathered to make the sediment that goes to sedimentary rocks. And then sedimentary rocks have to be buried very deeply for them to become metamorphic. And the metamorphic rocks have to be buried even deeper and heated up more to become magma so that you can start the process over again. That overall cycle is your rock cycle. The sedimentary process is about 1/3 of it, you could say.
Rock cycle starts with igneous rock and breaks down to sedimentary.
It's a cycle. You can start thinking about it wherever you want. But it's easiest for me to explain it starting at magma.
I have a question.
Yes, please.
So I just want to get this straight. So waves are fueled by or created by wind, while tides are not fueled, but like
Powered
the moon
by.
affects the tides, right?
It sure does. The energy for tides comes from the gravity pull of the moon.
What's the difference between waves and tides again?
A wave is, think of it as a column of rotating energy that is moving through the ocean via the energy is passed from the wind to the water, and then the water is moving in the direction that the wind was blowing it.
Yes.
You ever stood on a lake or near a lake? You can't stand on a lake. But if you stood near a lake and it's nice and calm day and then the wind starts to pick up and you see the waves start coming into shore. Right.
I have never been on a lake, but I have been to a beach before.
Okay. Similar sort of concept, right?
Mhm.
The direction that the wind is blowing is giving the energy to that top bit of water, which then imparts that energy in increasingly small amounts the deeper you go. Which is why when you get deep enough into the ocean, there's no waves, there's no water moving because the energy can't get that far. Whereas with the tide, the water is literally being pulled toward the moon by the gravity of the moon. But it can't get there. You ever watched a show that came out a few years ago called Moonfall? Did you guys see that? No? It's not very good. But one thing that they show is that and I guess this is spoilers, some alien entity has gone into the moon and is pushing it essentially closer to Earth in an attempt to wipe out humanity. Okay, so as the moon gets closer to the Earth, more and more of the ocean gets sucked up into the atmosphere towards the moon. And so part of the movie is you see vast, just globs of water coming out of the ocean and rising in the atmosphere towards the moon as it approaches the Earth's surface. And then buildings eventually start getting pulled off the surface, and cars and people and trees and mountains getting ripped off the Earth's surface, being pulled towards the moon. It's not exactly how it would work, but it gets the point across that the moon has a powerful gravity pull. And that's what's happening with our tides. There's a bulge of water in the ocean that is always being pulled towards the moon. And that's what makes high and low tides across the Earth's surface.
That's why they sail out at a certain time and then sail back in at a certain time? Or does that not have to do with the tide?
It kind of has to do with the tides, but it also has to do with the wind. Regardless of where the tide is, I mean, if you live on a mud flat or near a mud flat, so you have a mile of mud at low tide, and your boat might get stuck anyway. But regardless of where the tide is in any other circumstance, with no wind, you can't really go out and come back. So that has more to do with the heat distribution across the Earth's surface as the sun is rising and setting. In the mornings, the land heats up faster than the ocean does. And so there is warm air above the land and cold air above the oceans. And that warm, high pressure zone moves out over the land, making that wind. Whereas in the evening, as the sun is setting, the land cools off faster than the ocean does. So now you have a high pressure zone above the ocean, moving into the low pressure zone above the land, making that wind carrying the boats back. Yeah.
How in depth is the test going to be over natural disasters like earthquakes?
How in depth is over natural disasters like earthquakes? We have lightly discussed such things, but we actually have a whole lecture about earthquakes coming up in Module 3. Okay, so I won't ask questions specifically about earthquakes or too deep about them, I should say, until we have learned that. I'll never test you on something that you haven't already gotten in my class, right? That wouldn't be terribly fair, would it? So any actual serious questions about earthquakes, trying to get you to explain things about them, that's something that might happen on the final because we discuss it in Module 3. But not something in this exam because we haven't discussed it too much in Module 2 or 1. I've talked about it, but not too deeply.
So the final is going to go, is it over, is it only, sorry, I can't speak.
That's okay.
So the final is going to go over, is it going to, is it, gosh.
It's okay. Take a deep breath. Try again.
Is it only going to go over Module 3 or is it going to go over everything?
The final exam is cumulative. So that means everything.
Is your thing supposed to be red, flashing red?
I'm sorry, is my what supposed to be flashing red? That probably means that it's not recording any of your audio. So it may not have charged correctly.
Okay.
Can you pick it up and speak into it?
Mic check 1 2.
Do it again.
Mic check 1 2.
It's picking you up. It's just low on battery.
Okay.
So if it dies at any point today, I'll just keep repeating the questions that y'all ask as you ask them.
Okay.
Okay. Yes.
Will there be anything on those, what are those maps called?
Topographic maps. Great question. No. That is lab material, not lecture material. You are getting your, let's see, how much longer do we have in the semester?
This week and then next week.
This week and next week. So next week is finals? Okay. So you're getting your lab exam on Thursday this week. Next time we meet, you will be getting your lab exam. Please, 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 please have all of the work that you want for labs 1, 2, and 3 done, and 4 done by Thursday. Because that's when we'll be taking the lab exam after lecture. We will have the hour-and-a-half blocked after lecture for you to take that exam, or you can take it at home later if you wish. There is a physical set that I will give to you here in this classroom, but there is also videos of each sample online, like what my online students have been doing. It's entirely up to you as to when you want to take the exam. You can always come back later on Thursday or Friday or whatever to take it in person if you'd like as well. But Lab 5, the topographic map exercise, will not be on this exam. It also won't be on the lab exam. Lab 5 is the only content that I don't test you on.
So it will be on the final exam either.
It won't be on the final either. I may ask you questions concerning topography, but there will be no question of identify the elevation of this location on this map that I give you a piece of, right? It doesn't fit in to the rest of the lab material. I need to teach it to you because it's something that everyone else in every other geology program everywhere learns. But for me to do a topographic map question on the lab exam, I would need to drastically shake up the way that I have the lab exam organized, which I could do. I haven't. So for now, let's just stop at lab 5 you won't be tested on. Your lab exam will go over only identification. I can tell you more about that right now if you wish, since it's only a few days away. There would be 12 samples to identify on your lab exam. 3 from each of the labs. So 3 minerals, 3 igneous rocks, 3 sedimentary rocks, 3 metamorphic rocks. And me being the benevolent professor that I am, I tell you which is which.
What?
Yeah, I know, right? I say, this is a metamorphic rock. This is an igneous rock. This is a sedimentary rock. Right off the bat, I tell you. And then I say, these are the properties you need to give me. That's okay. I'll just repeat all your questions before answering them. So really, all that's up to you is to look at the sample, watch the video, or look at the sample in front of you if you're here in person, and then read my request. Okay, give me the approximate proportion of ferromagnesian minerals, and is it vesicular, and all of these things, and then you just basically fill in the blanks there with what you're observing. And on top of all that, I give you a word bank of all the possible names, all the possible rocks or minerals that could be on the exam. So really all that's up to you is to remember, based upon your lab experience, how you identify these things based upon their properties. Okay? Which is what lab has been all about. Yeah. That's your lab exam, yes.
Do we need to know about, like the Massachusetts thing and the mud things and
The barrier islands?
yes, and like when you build dams, do we need to know about that stuff for the exam?
Are these referencing the same lecture?
Yes, I'm looking at lecture 8.
Okay, so you're asking about barrier islands and dams and...
Yes, point bars.
Oh, okay.
banks,
Yeah, okay.
those.
Okay, yeah. So lecture 8 was about running water and groundwater and mass wasting. The conversation about Massachusetts and the barrier islands, that was lecture 11, shorelines and ocean floor. Yeah. So anything that's in module 2 is fair game. Absolutely anything I talked about in lecture for the last 2 weeks is fair game. So again, I will counsel all of you, if you're having a hard time thinking of questions in the moment, look through your notes, see if there's anything in there that you do not feel confident about. If you wrote half a page about this and half a page about that, but then this other thing has 1 sentence, it might be worthwhile to ask me to elaborate on that last thing so that you have a little bit more information to work with. Okay. For my online students, unfortunately at this point, it is too late to send me questions about this. I did give you all a week's prior warning that you could send me questions that I could answer in the exam review. What you can do is learn from this and ask questions before the final exam review in a few weeks. Send me those questions no later than the day before I actually do the review. What else? Yeah.
Are there any human activities outside of climate change that can accelerate, like coastal erosion?
Human activities outside of climate change. Are you constituting climate change as a human activity?
I would say like human-driven climate change, not like naturally occurring, like caused by molecular cycle.
I would edit that slightly to not human driven or human started, but human aggravated climate change. Climate was already changing before we had the Industrial Revolution. But to answer your question, yes, there are absolutely things that humans do that can affect the shorelines besides the natural occurrences of climate change, right? You remember I talked about how you can dredge sediment? So we can pull up millions of tons of sediment from one location and dump it somewhere else. That's affecting the shoreline, right? Sometimes we do that to re-energize, to reinvigorate a beach that needs a lot of tourism to keep economies alive. We build out jetties in front of natural river systems, right? To stop sediment from blocking up those river systems. Now, if that happened, if sediment did block up that river system, it's not like all of a sudden the river would back up upstream. No, the river will carve its way through somewhere else and deposit that water and sediment out in the ocean somewhere else. Think of the Mississippi River, right? Pretty much the entire bottom half of Louisiana is delta, built on delta, built on delta, built on delta. As the river changes course to accommodate all of the sediment that's being deposited in front of it, right? So that would happen, but that's not very useful for if we want to say have a boat portage upriver, right? We need to have that one deep channel that all our boats can go up and down. So we build jetties out in front of it, and that affects the natural erosion of that coastline. So yeah, there are absolutely things that humans do outside the bounds of events that occur through climate change that affect shorelines. Good question.
What's the most dangerous natural disaster?
The one you're in at the moment. I'm not saying he's in one. I'm saying that the most dangerous natural disaster is whichever one you're in at the moment. If I'm experiencing a landslide, I won't care much about tsunamis, will I? I won't be pondering the dangers of volcanoes if a million tons of rock are about to fall on my head.
Okay, then let me rephrase it. What is the most damaging natural?
The most damaging one. Ah. The most widespread, universally damaging natural disaster to human infrastructure would probably be earthquakes. I was almost going to say tsunamis, but earthquakes tend to be a little more common. Tsunamis, people live more near more coastlines than fault zones, but the earthquakes will knock down whole cities, and tsunamis only really occur when in proximity to some ground movement like an earthquake. So I'm going to say earthquakes, yeah.
What about hurricanes?
Hurricanes are in distinct parts of the world, like the Gulf Coast area of the United States, a little bit around Australia, Southeast Asia. It's not something that is a potential to go everywhere in the world, right? So those are acutely damaging, right? Very damaging in small areas. Earthquakes have the potential to happen in a lot of places. Tsunamis are restricted to coastlines for the most part. Good question. Thought-provoking question. I like it. Do y'all know what to do if there were an earthquake? Stand next to the window. Yeah, that's a great call. All right, so he's going to go stand next to the windows. Okay, everyone clear on that? That's his spot. No, under the tables is the best bet. Yeah, if you have a good solid doorway, like if there weren't glass above these doorways, I'd say stand under a doorway too. But I don't want you to get showered in glass. Doorways tend to have strong structural support. And if you're under a doorway, it's harder for things to fall on you because there's nothing above you but a doorway. Right? So if I'm standing in a doorway, ceiling tiles can't really fall on me, or light bulbs, or cross beams, or anything like that. Yeah. Trying to leave the building can be tricky. We're on a second story, and if we're on the third story, it's even worse. Bless you, by the way. If you're on the first story, that can also be tricky because by trying to go out in the hallway and exit the building, things could fall on you. What the immediate danger if you're in a building in an earthquake is get under something that will protect things from falling on you. In a multi-story building, it's really tricky though, because you don't know if the top story is going to fall on you. Yes, and a table won't help much if we're on the bottom floor in a chemistry lab and we hide under a lab table, it won't help much if the top 2 stories fall on them, right? But by getting out in the hallway and trying to leave, you're taking a different risk. So pretty much everyone recommends the best, safest course of action to take is get under a table, because it's more likely something on the ceiling is going to fall on you than that another story is going to fall on you. In a building like this that's made pretty much out of wood and glass, or metal and glass, it's not terribly earthquake safe. Glass shatters, metal breaks, bends, warps. Interestingly enough, the safest kind of buildings to be in during an earthquake are older buildings made out of wood, because wood will bend and flex. You had a question, Anthony?
So, like you said, like the ceiling could collapse. Couldn't that also mean like let's say there was an earthquake, could the ground below us collapse and we just go down?
Okay, so could the ground below us collapse in an earthquake? That depends on what's under you. The ground can't collapse unless there is something empty underneath of you for it to collapse into, right? I think there is, under this building, some small basement areas, mostly for infrastructure like air conditioning, things like that. But there isn't a whole basement underneath of here. Wilkerson has a whole basement under there, and it often floods with water, right? Do you guys see the pictures from last year of that? We had that torrential downpour here last year, and the entire basement of Wilkerson got flooded. Like, they lost power, and they couldn't figure out what was happening. And so our IT people opened the door to go to the basement, and the water was up to only 3 steps away from the top of the staircase. There was 12 feet of water in the basement of Wilkerson. It broke through the basement wall. Yeah, so the water, instead of draining away from somewhere, weathered its way through the basement wall and flooded in. Yes, it's great.
Flood infrastructure? No, we have the basement building of our college, one of our colleges.
You know what's funny? Our pool. How many of you have gone swimming in the pool here at the sports center? Yeah, we got a big pool.
Saying it's closed.
I know. It's because we have lots of lifeguard issues. I used to go swimming in that pool every day. And then for the last year and a half, we have had a heck of a time trying to find lifeguards. We have some now, but the pool can only be manned half the day. So, but another problem we have with that pool, it's old. That sports center was built in the late 70s, I think. For a building that sees that much traffic and, that sort of thing, yes. But the pool has a leak somewhere, and we can't figure out how or why, but 100 gallons of water is lost every week or something, and they have to keep replacing it, and we have no idea where it's going. We don't know where the water's going. It's going somewhere, it's leaking out somewhere, and we can't figure out where it's going. And I'm thinking, there might be some water-worn like tunnel or of some kind underneath the sports center somewhere. And
Imagine swimming one day, you just get into the hole.
oh yeah, no, that wouldn't happen. It's probably happening in some of the storage holding underneath of the pool, but or to the side of the pool, but it's getting lost somewhere. And wherever water flows, it's weathering. You know, there's probably some gap, some tunnel, some cavity of some kind under the ground somewhere. Huh?
What?
Someone's drinking it?
I'm not drinking with no.
Good.
Water.
Good. Don't do that. You'll die. Pool water, not good for you. Highly chlorinated. Yes.
Can we talk about the glaciers? Like what will be on?
Specifically, what about glaciers? If you want to know about glaciers, I recommend watching that lecture.
I just want to know what questions are thinking about glaciers.
Yeah, sure. The questions that could be about glaciers are anything we learned about glaciers. I mean, I'm not gonna specifically tell you what's gonna be on the exam other than the subject matter, you know? It's if I tell you to be prepared for one thing, then you'll ignore everything else to be prepared for it. Unless it's like, yeah, I would.
Continental glaciers. Can you talk about continental glaciers?
I'm not sure what you mean. Every glacier is a continental glacier. Yes.
I thought
All glaciers only occur on continents because only continents can be above the snow line. Glaciers form on any land that is above the snow line long enough for snow to collect. That only happens through tectonics, which means by definition, it has to be continental. Even Hawaii, which has some volcanic peaks above the snow line, is part of a continental process, even though it's mostly made out of that mafic rock. It can't get that high. It can't build up that high without Bowen's reaction series taking a little bit longer. Okay? But anything else you want to learn about glaciers? Any other specific questions? I'm happy to answer. Weird comment. So you know how Trent likes to 3D print in yellow and blacks? You look like he 3D printed you right now. He actually did.
It failed though.
It failed. Oh no. Misprint. Yes.
Can you expand upon
Classifying
classifying
coastlines. You mean as far as submergent and emergent?
yeah.
Okay. A submergent coastline is one that is losing land to the ocean. This is independent of typical ocean rise or fall. This is actively the land is sinking underwater. This happens very slowly. Why does this happen? Well, typically what will happen is a passive margin will fill up with sediment. That sediment is effectively weighing the continent down. And as the continent gets weighed down, it kind of sinks lower into the mantle. Okay? Same way that bowling ball on that memory foam pillow I used as an example before, right? As that happens, as it sinks lower into the mantle, the ocean has the opportunity to move further inland. That's what's happening on the east coast of the United States. That's why the Chesapeake Bay is an estuary. It's a flooded river, okay? You remember seeing that picture of Chesapeake Bay? Then you've got your emergent coastlines, the ones that are gaining land out of the ocean. This will happen typically along a subduction plate boundary, where two plates are colliding together. One subducts under the other, or it could happen actually where two continental plates collide into each other as well. But in either case, land is rising out of the ocean as a consequence. This is happening in California. They gain a few centimeters of land every year. which doesn't seem like much, again, until you put it into a geologic time context. Same as tectonic plate movement. Remember how fast I told you tectonic plates move?
Like 5 millimeters a year.
More than that, 5 centimeters a year. They move on average about 5 centimeters a year, which isn't enough to notice in a year. That's about how fast your fingernails grow, right? We have to trim our fingernails every now and then or chew them off, however you choose to do that, right?
Teeth are free.
Teeth are free.
To an extent. To an extent.
Anthony doesn't even want to spend money on a fingernail clipper. It's like cheapskate. But imagine how long your fingernails would be after 1 year if you just didn't clip them at all, right? You'd have talons, right? You'd look like Nosferatu.
Have you seen that movie? The new one?
I have not seen the new one. No. Although, interestingly enough, this Friday, when we are having our class movie night, 6 p.m., we are having our class movie night watching Dante's Peak this Friday here. Well, it'll be in 203, but in this building at 6 p.m. this Friday. At the same time, the Globe across the way, they're doing a monthly film night, classic film night. They are showing the original Nosferatu, the silent film from the 20s over there. Yeah, they're showing it over there. Yeah. So if you wanted, I mean, they're showing at the same time, so I guess I can't really say if you wanted to catch a double feature, but our movie's probably longer than theirs anyway. Please come to ours. Yeah.
For emergent coast, did you say divergent or subductive?
Convergent plate boundaries, which often include subduction. Remember, convergent plate boundary can happen one of two ways. You have a less dense plate and a denser plate, and the denser plate subducts under the less dense plate. Think Pacific plate, North American plate at California doing this, right? Or you have less dense plate and another less dense plate, two continental plates that crash into each other, and instead of one subducting under the other, they crunch up high in the atmosphere and deep underground. They make a mountain range. This is what's happening as India runs into the Eurasian continent, okay? This is what made the Himalayas. When you look at that map and you see the massive Himalayan mountain range, no, don't tell me you have a poor connection. Don't do it. Okay. Massive Himalayan mountain range is a result of two continental plates, the Indian subcontinent running into the Eurasian continent. Neither one is more dense than the other, and so you get the Himalayas as a consequence. Those Himalayas go a lot further underground too, kind of like an iceberg. You see, Everest is X amount of distance tall. It's the roots of that mountain range go 3 times further underground. Yeah.
This might be unrelated, but do coral reefs have anything to do with geology?
Yes, coral reefs have a lot to do with geology. There's the obvious answer there where they can become fossilized. And, you know, we have lots of fossils we pull out of them. They make limestones. The activity, the life that occurs along fossil reefs makes a lot of limestones. But also, the animals that live in the coral reef that build up the structure of the coral reef, the coral itself, they build their skeletons, they build their structures from recrystallized minerals. How do the dissolved minerals that they use get in the ocean in the first place? Well, those organisms have to get it from somewhere. It has to be in the ocean to begin with. How does it get in the ocean to begin with? If I have a coral reef made entirely out of animals that use calcite to make their shells and skeletons, that calcite that's dissolved in the water, which they use, has to have gotten there in the ocean somehow. Weathering and erosion, right? A rock that contains those same ingredients, say a limestone on land, is dissolved, carried by the water system, be that groundwater or running water like a river, out to the ocean, and it's dispersed in the ocean. And the ocean is filled with all of these dissolved minerals, which are then utilized by the animals to make their shells and skeletons. Okay? Which is why ocean acidification is a problem. As the concentration of carbon dioxide in the atmosphere increases, the natural flux between Earth's atmosphere and our oceans has to compensate. Flux is that balance, right? All things in nature seek stability. There is a balance between the atmospheric concentration of gases and the ocean concentration of those dissolved gases. So as the increase of carbon dioxide in the atmosphere happens, there is an increase in the amount that becomes dissolved in the ocean. This increases the ocean's acidity, right? Carbonic acid acidity, which is hostile to any organism that's made out of a calcite shell or skeleton. And so as time goes on and the acidification gets worse, we are seeing more of these organisms struggle with their shell structures. They are not as strong, they're not as thick, they become more brittle, easier for predators to kill, right? Or just collapsing under their own weight. So we're going to see coral reefs across the world struggle with this as time goes on. Yeah.
Do glaciers only occur on Earth?
No, that's a great question. Glaciers do not only occur on Earth. There are glaciers on Mars, and you can see them. If you look at a picture of Mars, you can see glaciers at the pole. Yeah. Any process that we observe here on Earth, it is reasonable to assume that those occur everywhere else too, or have the potential to occur everywhere else too. Glaciers can't form on Venus. Temperature's too high. There's no snow line whatsoever, right? Glaciers can occur on Mars. It has a much lower snow line than we do here. Mars is cold. It's further from the sun. It doesn't have an active magnetosphere to protect it from solar radiation. Its atmosphere is blown away, which means it can't retain a lot of heat, much smaller snow line. Enceladus, Titan, Europa, they're just covered in ice. Their entire crust is made out of ice. It is extremely cold on that surface. But all of these are driven by the same processes that we observe here, the same physics, the same cause and effect scenarios that we observe here on Earth can be applied everywhere else. I hope that's one thing that you take away from this class, that appreciation of the wonder of a universe by understanding our one little part of it. What else? There's actually a guy I know, Dr. Pascal Lee. He works for the SETI Institute. That's the Search for Extraterrestrial Intelligence. They're a branch of NASA. He goes to an island off of Greenland every couple of years. He takes an expedition. And the whole point is he specializes in the study of Martian landscapes and how equipment would work on Mars, and how glaciers on Mars interact with Martian terrain. And he studies that on this island because this island is just dead and barren. There's not a living thing on it. It's just red rock. It looks like Mars when you're on it. And so he observes the ways that things interact with that landscape and interprets it as a near Martian landscape. I've been talking to him for probably a couple of years now. We hold out hope that one of these days he can take me out and I can be out on that at that facility on that island. for a couple of weeks so I can get some hands-on experience with that. It would be pretty cool. What else? Please don't feel self-conscious about asking questions. Guarantee someone else has the same questions you do.
Have we talked about icebergs?
Icebergs were a component of our discussion about glaciers. Icebergs occur when a glacier meets the ocean and chunks of it fall off into the ocean. Just fact check myself here real quick before I share something. That's right. Bless you. Okay. Okay. The largest iceberg is known as A23A. It fell off the Filchner ice shelf in Antarctica in 1986, but it's so big that when it fell off, it got stuck on the sea floor for a while. And then in December, it broke free, and it's now moving away from Antarctica. This glacier is 3,500 square kilometers.
You could potentially live on it.
Oh yeah, I mean, that's larger than most cities. It is 400 meters tall.
Is it possible to live on an iceberg?
Is it possible to live on an iceberg?
Yeah.
Yes. If you want.
Are we sure?
Yeah. It'd be cold. Whatever you brought with you.
You could like make a light on an iceberg though. Like you could do that.
You never get a date on an iceberg.
No.
I'm just saying.
This iceberg is so large you can see it from space.
That's the thing.
Here, let me turn this on so I can show you all this. Looks like it's going to slam into South Georgia. Um, yeah, here, look at this. So here's a picture of Earth. You see that little white dot right there?
Yeah.
That's the iceberg
Wow. And
there.
that's-
Yep. And it's gonna slam into these islands, South Georgia.
So would it like completely demolish those islands?
It's not gonna plow right through them because rock is still, that's attached to the ocean floor, right? But it is gonna grind up onto the side. Let's see, how far away is it supposed to be?
It won't melt any by the time it gets there.
Huh?
It won't melt at all by the time it
I
gets
mean, yeah, it's gonna lose some mass by the time it gets there. This isn't the first huge iceberg to threaten South Georgia. In 2004, one called A38 grounded on its continental shelf, leaving dead penguins and seals on beaches as massive ice chunks blocked their access to feeding grounds. Yeah, it's been moving fast. Let's see when it's supposed to hit. When will A23A hit South Georgia? It could hit sometime in the next 2 to 4 weeks, depending on the currents. It'll be interesting to see.
How does Mac do the islands, what else exactly should you do?
Well, if it grinds itself up onto the banks of South Georgia Island, it's going to be there for a very, very long time. It's going to change the ocean chemistry. It's going to change the way that the currents and the tides affect that area. Depending on where it lands, it could essentially act as a massive barrier island. It'll have massive effect on the ecosystem. Those animals, it could displace some animals. It could stop them from being able to migrate. It's probably going to, as conditions warm, it's probably going to make the ocean around the South Georgia area much fresher than it would be otherwise, which will be hostile to a lot of the native species. The people that live on South Georgia Island, they rely a lot on fishing industries. So that'll negatively affect them. Yeah. Huh?
Isn't that where Forrest Gump shrimp had his shrimp boats off of Georgia?
I don't know, but this is the South Georgia Islands.
Oh.
Yeah. Yeah.
Can the deposition, the type of elements in sand affect how sand dunes are formed? Or?
The type of sand
Yeah.
affect how sand dunes form. The way that sand dunes form is a product of physics and less a product of what the material is made out of. So you can have sand dunes made from a more feldspar rich sand. There are green sand beaches and pink sand beaches and black sand beaches. Dunes can form equally on all of those.
They all form the same kind of thing.
Yeah, physics is physics. Yeah, the color of the sand, the material involved isn't really the main factor in determining that. What else? I feel like our questions are drying up. Are y'all just looking at your notes, making sure they're where you want them to be? Give you a couple more minutes. See if you have any more questions. All right, friends, do we have any more questions? Does everyone feel really confident in taking the exam then? Confident enough? If you aren't confident, then that means you should be asking questions. Okay. Well, I'm going to end our exam review here and open the exam. Any of my online students watching this later on, your exam is now open at this time.